So I have a few examples for 15.1. Last time we talked about bar graphs and histograms. I'll remind you about bar graphs, and then we're going to do a bunch of histograms.
Is this still 15.1, professors, or have we moved on to 15.2?
It's still 15.1.
Thank you.
I just want to put bar graph, histogram. Okay. Okay, so this is when your categories don't when you have separate categories, so the bars don't touch, kind of shows the distinct categories. And in a histogram, you have intervals, and from one to the other, those bars will be kind of touching. We're going to practice this today. Okay, we're going to construct a histogram for the following frequency distribution. All right, the side has an interval from 0 to 4. And it includes things like 4.5 and 4.9 and 4.99999, close as you can get till 5, but you start at 5 on the next interval. And it goes up to 9. And values as close as possible to 10, but 10 is actually going to be the next set, which goes from 10 to 14, and 15 to 19, 20 to 24. Let's just stop there. I'll put this note up in a second, but these are called classes. For the first class, the frequency is 5. Next one is 7. 4, 2, 1. We need to start at 0 and end with a number close to, put 25. We're getting as close as we can to 25 here. So 0, 25. From 0 to 4, we want a height of 5. Actually, the largest height is 7. So let's put that at this here.
Professor, in the terms of designing, do we have to have it like in the intervals like you have like 0, 5, 10, 15, 20, or like I wrote it down as just each of the categories or the classes. So I wrote like one tick mark on the histogram has 0 to 4. Next one has 5 to 9. Can it be that way, or does it have to be like that for our X intervals?
If you have 4 here, the bar is actually going to go up to 5 still. So I think you want to use these lower numbers of the class, they're called like lower class limits, as the marks.
Okay, thank you. That makes sense.
And I'll put all this vocabulary up in a second. So these are classes, each 0 to 4 is a class, 5 to 9 is the next class. And then this is the lower class limit, that's an upper class limit. And we labeled the lower class limits on the graph. Okay, similar to the problems we did before. Put up to a height of 5 for the first class. And shape. Yeah. 5 to 9, so up to 7. Next one goes up 4 and over to 15. 2, then 1. So 2, 1, almost there. Okay, so first thing we're going to write down was the classes. So the classes are categories in which data are grouped. Okay, the smallest number in a class is called the lower class limit. I feel like there might be a better way to say that, but that should work. The smallest.
Could we synonymize it by saying the minimum value or something like that?
Yeah, that works. I mean, I'm not going to be picky. So, yeah, solid. Well, yeah, like the min for the class, but it might not be. Let me think about it for a second. It makes sense to me, but I am just going to put this like official like lower class limit up because sometimes the min can have a different meaning, which is actually in the next section. But I get what you mean. Okay. Is lower class. I'm not going to test on any of this really, just putting it up for side notes. The I put max a class, as long as that part's in there, is the upper class. Anything else? I think we just want to make another histogram. So construct a histogram for the frequency distribution. Okay. The classes start at 40. I'm just going to put class. 40 to 45. This was 2. The next class is 46 to 51, and its frequency is 5. Then there's a class 52 to 57, frequency of 7. And we're going to put one more in here. So from 58 to 64, the frequency is 3. Cool. I'm going to get 40, 46, 52, and 58 ready. On another line. 46. And then I'm going to put just a small space here and the next axis.
Do we have to put, if we're drawing it, because of course on Canvas it'll already be pre-drawn, but for like, you know how when sometimes when you're making graphs you have to put like that Z if you have like a little Z if you jump right from like 0 to a larger number. Do we have to do that, or is it fine with a histogram?
It's okay. It would be okay with me. But yeah, there's sometimes a cool mark like something.
Right, yeah.
I need, again, 7 is the largest number, so let's get that at the top. 1, 2, 3, 4, 5, 6. Okay, the first class goes from 40 to 40, actually up to 46, and has a height of 2. So it kind of looks like you include 40, but not, you get really close to 46 and don't include 46, and that's where your histogram, or your bar is, I guess. And 46 up to, but not including 52, it's height 5. Okay, this class has a height 7. Over, down, shade. And then height 3, then we're done. Let's see if I can scoop everything. Oh, 65. So I think I have one more. We'll make it kind of short. But are there any other questions about histograms? Okay, let's do this last one. Make it easy. All right, we'll do a class from 20 to 29, 30 to 39, and we'll go 40 to 49. Then there's 1, 10, 2. So mark 20, 30, 40 on a number line. Like this. Actually, I also always put 50. Goes up close to 50. 10. Let's go like 5. Cool. All right, so a little tiny bar right here. And jump up and over. And then a slightly large bar. All right, that is the end of 15.1. And we want to go into 15.2. This chapter only has 2 sections, but each section is full of information. So see how much we can cover. Sorry if you can't, I don't know. The drawing looks like it has a big glare on it. So the title is mean, median, mode, and percentiles. Oh, so to introduce the mean, I've got notes about summation notation. So first, we have a set. We're going to let the set of x sub 1, so x subscript 1, x subscript 2, x3, dot, 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 up to x sub capital N. And then close the set. Let this set denote a set of n numbers, capital N.
Does X capital or subscript capital N represent the final number given? in a certain example. Okay.
Yeah, that's perfect. Okay. It's a set of n numbers. X1 is first. Number X2 is the second. And I'll write down what was just mentioned at the end, but we have like dot, dot, dot.
What's after first? Oh, number sign. Never mind. It just showed up.
Yeah. Okay, that's a glare. Nope, there's no fixing it. Okay, we're back. Well, actually, this might help this way. This way. Better, a little bit. So x sub I is the ith number. Yeah, number sign. Then we've got x sub n, that's the last number. And we'll put this all together in a sec, but I want to put just the general symbol, this sign here. You have like this flat, so flat. This is a summation symbol. And I'm just going to put summations. It means add. So you put in a value and add it to the next value and add it to the next value. We're going to practice in a sec. Okay. We have the sum from I equals 1 to capital N of x sub I equal to x1 plus x2 plus x3 until you get to the top plus x sub n. Okay, we have a few examples to do, so it should make sense with practice. Okay, the set that contains 1, 2, 4, 5, and 8. Find the sum from, let's see how many, 1, 2, 3, 4, 5. The sum from I equals 1 to 5 x sub I. So this is x1, x2, x3, x4, x5. It doesn't matter what order they're in, just as long as you pick one to start and then you go down the list, get each value. So we want 1 plus 2 plus 4 add 5 add 8. This is 3, 9, 8, 17 with 3, 20.
Professor, how come and on top of the sigma sign is 5 and not 8?
It's the number of X values that you have. So it's like 1, 2.
Oh, that's what n means, not sigma n. Okay.
I'm gonna have to count.
Or x, not xn, it's n. So n is the number of them versus xn, which is the final number of them. I'm confused, sorry.
No, I think I should write that down. Capital N is like the number of elements in the set. That I needed it over here. One more. So for the set contains -1, 0. Get it up here. Something set with -1, 0. 1, 2, 5, and 10. And I do see the question in the chat, which I'll get to in just a sec. Let's write up the question. Find sum I equals 1. 1, 2, 3, 4, 5, 6 of these. X, y. Okay, so someone asked about this sign. I've only ever heard it called summation sign. I've seen a sigma symbol, which it's, and I can, of course you could stop and Google it. This should be sigma, which is kind of a value that comes up with all this, all the kind of topics we've been going through, statistics related topics. But sigma and summation are not really the same. So I'm going to say no, I don't think that we can call it sigma. But I'm going to Google it first before I say that.
I have a quick question. For the example where it's like for the set, is those the numbers that contain the number of elements in the set of n?
Is capital N?
Or I didn't hear what that was for. Yeah, that.
Yeah, capital N. Yeah, the number of elements that are in this set. Like this set has 1, 2, 3, 4, 5, 6. So that's the capital N.
So when Austin asked the question about how do we know to put 5 on top of the summation, what are you saying?
If you can count them, it would be nice to put it here. But actually, some people just leave this part like this. And it's just telling you, make sure that you add all X values. Actually, you don't need this anymore either. Add all X values for X in the set. That's what you could say too. So
Okay, thank you.
yeah, you could just leave like this, as long as you know, just make sure you get every single one. Okay. I am gonna check this question about the symbol though. If anyone has an answer, you can share it in the chat. That'd be cool. Summation. Oh, I see. Oh, it's the Greek letter sigma.
It's uppercase and lowercase.
It's the uppercase Greek letter.
Lowercase.
It is the same.
The O with the little curve.
Yeah, it's the same. But in this setting, we're using this symbol, uppercase Greek letter, I think, to mean add. Let me make sure I'm translating that. This symbol is generally used as to denote the sum. Yeah, okay. So this is a Greek letter, and we're using this Greek letter to like denote the sum of a set of elements. Cool, thank you. I learned something new. And we got an answer of 17. So I will write down what the work is really quick. Thank you. Let's do one more. It's a large set.
Professor, say just one last question regarding this past example. Say we weren't on Canvas and writing the actual answer. What label would we have to put in front of like 17? So like da 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 equals 17. Would we put summation x as like the label? If we had like, right, do you know what I'm asking? Like when I say label,
I'm not too strict of a grader. So if you just put 17, that would be okay.
Okay.
Yeah, it's okay. I want to find the sum. Let's just do sum x. We're just going to label it like that. 4. The set has 5, 10, 15, 20. 25, 30, 35, 40. Okay, the sum of x. Another style is to put a little tiny x here, which means for all x, but still sum all x values and get 5 plus 10 plus 15 and 20, 30, 35, 40. That's the end. And my answer was ... 200 total. So we're going to use this piece in the first part, like the first main topic of the chapter, which is the average. Okay, so average and mean are the same. Average slash mean is the average of a set is called the mean, and equals the sum from I equals 1 to n of x sub I. And then divide that number by capital N. So again, average equals mean equals sum x over same thing. First example, we find the average of the set that contains, well, we'll get there. So find the average. Okay, set with the elements 0.5, 1, 1.5, 2, and 7. Okay. Gonna do average. Oh wait, someone got a different answer. Okay, let's back up. Back up to that previous problem and check the math. We got 180. Let's do it together. So I'm going to bring up Desmos. Thanks for checking my work, everybody. Going to the calculator. So it was 5, 10, 15. Oh, cool. Yeah, this is a nice calculator. And they have graphing calculators too. 20, 25. Make sure I don't miss anything. 40. Okay, cool. I made a mistake. That's cool though. 180. And I did it in my notes. That was the answer. Cool. Let's do this one carefully then. So 0.5 plus, well, actually, we'll write the symbols first. Sum all x values and divide by the number of values that you have. Zero 0.5 plus 1 plus 1.5. Do it. And there are 1, 2, 3, 4, 5 elements total. Okay, here is 2 plus 3 plus 7. Over 5, over 10, over 12, 6. Of course. Did that part, we did that part. I think we should do another average or two and then get to the median.
What's the correct form? Can it be in decimal form, Professor, or does it matter whether it's in decimal or improper fraction form?
For me, it doesn't matter.
Okay.
Yeah. This has to be the correct number. We're going to get, oh cool. Is that the reduced value? 12. This is 2.4.
Yeah.
Thank you. Either one works. One more. Let's go with find mean. Wait, average is same as mean. Yep. Okay. 37413. 536. We add all x values and then count how many there are, divide by that number. Where's... Right. 3 plus 7 plus 4 and 1 plus 3 plus 5 plus 3 plus 6 2, 3, 4, 5, 6, 7, 8. Yeah. And I have, let's see, 10 plus 5 plus 8 plus 9. So over 8. 15 plus, this is 17 over 8. 32 over 8, and you get 4. All right, next topic, or the next thing to cover is median. So the median is the value that lies in the middle of your data, which means you have to get your data organized in increasing order and then start on the edges and work to the middle. Okay, is. Well, we put the median of a variable is the value that lies in the middle of the data. Oh, when arranged in increasing order. It's not quite done. Arranged. So steps, we're going to start with the first step here is arrange data in increasing order. Step 2, find the middle value or values. We're going to put value parentheses S.
What does the bottom of that say? Of step 1.
Step 1, oh, arrange data in increasing order. I think we'll just start again. We'll list it down. And start looking for the middle value. And two things can happen here. So we'll call this A. If the number of values is odd, the median is exactly in the middle. If the number of values is even, the median is the average of the two numbers in the middle. All right, in this case, the median is the average of the two middle values. So it's not too bad after we start practicing. First example, we're going to find the median. And start here. All right, the set that includes 5, 2, 4, 5. Five, 9, 3. So we get our values in increasing order. Smallest number's 2, 9 will be at the end. Just make sure you don't forget anything. Don't leave any values out of this list. 2, 3, 4. 5, 5, 5. Go to the edges and work towards the middle. So maybe cross these out, and I have 2 pins. Cool. So let's cross this. And the next one. Next one. Right here. This is the median. Okay. We're gonna do the same.
I have a question.
Yes.
Okay, so say if we had an odd number and we had two numbers in the middle, say it was, but it was the same number. So like for an example, 5 and 5. Would the median still be 5, or do we still have to do the extra steps to figure out the average?
It turns out that it would be 5, and then you do the extra steps, that also equals 5 too.
Okay.
It would still be 5. I think I could even just, well, let me peek at my notes. Well, I just want to write down what we just talked about. Just like a different example. And I'm going to just skip the list. 2, 3, 4. How do I do this? Just put another 5. I think that'll work out so that when we cross these out, there's these two in the middle, and we average them. Need to do 5 back. So, good question. Nice example.
Thank you.
Next question for practice is the median of this set. All right. It has 123, 107, 114, 100, 107, 130. Close. Oh. Okay. Get the list in increasing order. First. Okay, take care of this one, and this one. 114, 123, 130. Work to the middle. And there's 2 numbers in the middle. So add them together and divide by 2 with 107 plus 114 over 2 equal to. And always you can check my math, but I got 110.5. Where are we? We still have, I think, 15 minutes.
That answer is confirmed, Professor.
Oh, I see. We got the right number. I think we'll do one more question for median, and the mode is pretty easy, and then we'll stop there. Okay. So this is a new example. Start fresh. Find median. Let's do 51120. 45913. So we arrange everything from 0, 1, 1, 2, 3, 4, 5, 5, 9. So start on the edge. Keep going towards the middle. Either you get a number in the middle or you get 2 numbers in the middle. When there's 2 numbers in the middle, we take the average. We could put 2.5 or 5 over 2. Either way is fine. All right, last thing to cover for today is the mode. The mode is the number that occurs the most, or numbers that occur the most. Let's put the value that occurs the most, or values. I'm gonna start again, as this is.
Professor, you said there could be set of numbers could be bimodal or trimodal, as well as just being a single.
We could have more than one mode, and I think what you're saying.
Yeah, more than one. It could have the possibility to have more than one mode.
Yes. Let's skip that. Let's go over. The set has 1, 2, 2, 2. 5, 5, 0, 5. 2, 5. Okay, there's 1, 2, 3, 4 for 2. I mean, 4 occurred. 4 occurrences of 2. 5 happens 1, 2, 3, 4 times. So 2 and 5 are the modes. Let's determine the mode. Okay, this set has 2, 8, 6, 4, 2. And 2, 4, 8, 8, 4. So let's do some color. 2 occurs. Let's see. 1, 2, 3 times. 8 is 1, 2, 3 times. 4 happens 1, 2, 3 times. So 2, 4, and 8 are modes. And I think we call that good. So that's the end for today. Just let you know what's coming soon. I want to go through dot plots, which I think are fun. And then after dot plot, we talk about shapes of distributions, and then later on we'll start doing percentiles after that. Okay, thank you everyone. Let me end here.